Now we'll be talking a little bit more about how an original relation and its inverse are related to each other. So note that inverse relations undo each other. So for example, if you have the original function f of x equals x plus 2, if you go through the steps and you calculate the inverse function, you'll find that it's f inverse of x equals x minus 2. So plus 2 switches to minus 2. They kind of undo each other, right? F of x equals 2x. The inverse will be f inverse of x equals x over 2. F of x equals 5 times x plus 4. F inverse of x equals x minus 4 divided by 5. So what we mean by undo each other, we'll see this a little more specifically. What I want you guys to do in numbers 8 and 9 is to plug one function into the other. So we're given, in number 8, for example, an original function, f of x equals x plus 2, and then its inverse function, f inverse of x equals x minus 2. And we want to find the compositions in both directions. So first I'm going to find f of f inverse of x. So I'm going to take f of f inverse of x, which is x minus 2, so f of x minus 2. And this will be, in place of x, I'm going to put x minus 2 plus 2. And then, of course, when I simplify this, x minus 2 plus 2, those cancel out, they add to 0. So I simply get x. So f of f inverse of x equals x. All right, and then if I go in the other direction and I want to find f inverse of f of x, that would be f inverse of f of x, which is f inverse of x plus 2. So instead of x minus 2, now I'm going to have x plus 2 replacing x, and then minus 2. X plus 2 minus 2, the plus 2 and minus 2 cancel out to 0, and those add up to x. So again, I get that the composition f inverse of f of x equals x. So you'll notice that the composition in both directions both equal x. And it's not so significant, well, it is significant that both compositions after simplifying equal each other, but specifically they equal x. So it's not like f of f inverse equals 5x and f inverse of f of x equals 2 or something. They're both equal and they're both equal to x. All right, number 9, we've got our original function, f of x equals 5x plus 4, f inverse of x equals x minus 4 over 5. Let's find the composition in both directions. So f of f inverse will be f of x minus 4 over 5, and this will equal 5 times x minus 4 over 5 plus 4. 5 over 5 cancels, so this gives me x minus 4 plus 4. Negative 4 plus 4, those cancel additively to 0, and that equals x. Going the other direction, f inverse of f of x is f inverse of 5x plus 4. So this will be 5x plus 4 minus 4 over 5. Plus 4 minus 4, those cancel each other out. So this leaves me with 5x over 5. Also simplifies to x. So again, notice that f of f inverse equals x and f inverse of f equals x. It's not that both of them equal 2 and 2. Specifically, they both equal x. All right, so let's let f and g be two functions, and we don't know if they're related or not, but we find out that f of g of x equals x, and g of f of x also equals x. Then that means that the function g is the inverse function of f, and we can denote it by f inverse of x. And actually, this will be true in both directions, so they're each inverses of each other. But when we find out that the composition in both directions equals specifically x in both cases, that tells me these functions are inverses of each other. All right, so for number 10 and 11, but for number 10, Are f of x and g of x inverses of each other? This is the question we're trying to answer. So to figure this out, first, I need to find f of g of x, which will be f of, in this case, x minus 9 over 4. And using f of x equals 4x plus 9 as the pattern, this will be 4 times x minus 9 over 4 plus 9. 4 divided by 4 cancels to 1, so that goes bye-bye. Then we have x minus 9 plus 9. Negative 9 plus 9 cancel out to 0. Simplifies to x. So we're on the right track so far. We got x for f of g. Now we want to go in reverse and find g of f of x. And this is g of 4x plus 9, which will be 4x plus 9 minus 9 over 4, replacing x with 4x plus 9. And up in the numerator, plus 9 minus 9 cancel out to 0. So this leaves me with 4x divided by 4. 4 divided by 4 cancels to 1, leaves me with x. So because f of g of x equals x and g of f of x equals x, we can say yes, f and g are inverses. All right, let's do the same thing again for number 11. So first I'll take f of g of x. And now for number 11, we have f of x equals 3x minus 7, g of x equals x plus 3 over 7. So f of g of x is f of x plus 3 over 7, which is 3 times x plus 3 over 7 minus 7. And notice before we had 4 and 4 and those canceled out. Now we've got a 3 and a 7. Those don't cancel, right? So all we can do is treat this as like a 3 over 1. I can multiply up in the numerator, so distribute that 3. So this gives me 3x plus 9 over 7 minus 7. And by the way, at this point, I can definitely see that it's not going to equal x, but let's go ahead and fully simplify f of g of x. So I can rewrite minus 7 as minus 49 over 7, right, to write an equivalent fraction. 7 over 1 would be equal to 49 over 7. So fully simplifying, I have my denominator of 7. I have 3x plus 9 minus 49, so that's going to be 3x minus 40 over 7. So that's f of g of x. So actually, already I know the answer is no. If even one of these fails, I know they can't be inverses of each other. But I'm going to go ahead and calculate g of f of x anyway, just to verify this. So step 2, g of f of x equals g of 3x minus 7. Oops, sorry. And so that will be, let's see, instead of x plus 3 over 7, I will have 3x minus 7 plus 3 over 7. And remember over here, when they were inverses, the 9 and minus 9 canceled. Up here we've got minus 7 plus 3, so we end up with 3x minus 4 over 7. Nothing gets canceled out. So f of g does not equal x. G of f does not equal x. So no, f and g are not inverses. Okay. So if you're asked if two functions are inverses, you find the composition in both directions. If both equal x, then yes, they're inverses. If the compositions equal anything other than x, then the answer is no, they're not inverses. And then finally, number 12, use the graph of f to draw the graph of each inverse function. So over on the left, if this is our graph of f of x, I'm just going to identify some points that I see. So for example, for our given function f of x, if we draw a little xy table, I see that we have the ordered pair 2, 0. We have 3, 2. We have 4, 4. And then, let's see, 1, negative 2, and 0, negative 4. So I don't need nearly this many points, but I'm identifying all of these points on my f of x function. Now, if I wanted to draw the inverse function, f inverse of x, if I were to draw an xy table for that, remember all I have to do is switch x and y, and ultimately that's what I'm doing every time I'm finding an inverse function. So 2, 0 becomes 0, 2, 3, 2 is 2, 3, 4, 4 stays, that will be in common between both functions, negative 2, 1, and then negative 4, 0. So I'm just switching all of my ordered pairs. So here's 0, 2, 2, 3, 4, 4. Again, we have that in common between both functions, negative 2, 1, and then negative 4, 0. So that would be f inverse of x. And just a quick reminder that the original function and its inverse are symmetric about the line y equals x. Okay, that's why they have this point 4, 4 in common, because that's where y equals x, 4 equals 4. All right, so over on the right, we can follow the same process. So for my original function, f of x, I see negative 4, 1. I see 0, 2. And then I see 3, 4. So if I wanted to graph the inverse, f inverse of x, I'm just going to switch the x's and y's around. So 1, negative 4, 2, 0, and 4, 3. So 1, negative 4, 2, 0, and then 4, 3. So that would be my inverse function. And again, a function and its inverse are symmetric across that line, y equals x.